Why is except pass a bad programming practice? I often see comments on other Stack Overflow questions about how the use of except column pass is discouraged. Why is this bad? Sometimes I just don't care what the errors are and I want to just continue with the code. Why is using an except column pass block bad? What makes it bad? Is it the fact that I pass on an error or that I accept any error?
As you correctly guessed, there are two sides to it: catching any error by specifying no exception type after except, and simply passing it without taking any action. My explanation is a bit longer, so it breaks down to this. Don't catch any error. Always specify which exceptions you are prepared to recover from and only catch those. Try to avoid passing in except blocks. Unless explicitly desired, this is usually not a good sign. But let's go into detail. Don't catch any error. When using a try block, you usually do this because you know that there is a chance of an exception being thrown. As such, you also already have an approximate idea of what can break and what exception can be thrown. In such cases, you catch an exception because you can positively recover from it. That means that you are prepared for the exception and have some alternative plan which you will follow in case of that exception. For example, when you ask for the user to input a number, you can convert the input using int, which might raise a value error. You can easily recover that by simply asking the user to try it again, so catching the value error and prompting the user again would be an appropriate plan. A different example would be if you want to read some configuration from a file, and that file happens to not exist. Because it is a configuration file, you might have some default configuration as a fallback, so the file is not exactly necessary. So catching a file not found error and simply applying the default configuration would be a good plan here. Now in both these cases, we have a very specific exception we expect and have an equally specific plan to recover from it. As such, in each case, we explicitly only accept that certain exception. However, if we were to catch everything, then, in addition to those exceptions we are prepared to recover from, there is also a chance that we get exceptions that we didn't expect, and which we indeed cannot recover from, or shouldn't recover from. Let's take the configuration file example from above. In case of a missing file, we just applied our default configuration and might decide at a later point to automatically save the configuration, so next time, the file exists. Now imagine we get a directory error, or a permission error instead. In such cases, we probably do not want to continue. We could still apply our default configuration, but we later won't be able to save the file. And it's likely that the user meant to have a custom configuration too, so using the default values is likely not desired. So we would want to tell the user about it immediately, and probably abort the program execution too. But that's not something we want to do somewhere deep within some small code part. This is something of application level importance, so it should be handled at the top, so let the exception bubble up. Another simple example is also mentioned in the Python 2 idioms document. Here, a simple typo exists in the code which causes it to break. Because we are catching every exception, we also catch name errors and syntax errors. Both are mistakes that happen to us all while programming, and both are mistakes we absolutely don't want to include when shipping the code. But because we also caught those, we won't even know that they occurred there and lose any help to debug it correctly. But there are also more dangerous exceptions which we are unlikely prepared for. For example, system error is usually something that happens rarely and which we cannot really plan for. It means there is something more complicated going on, something that likely prevents us from continuing the current task. In any case, it's very unlikely that you are prepared for everything in a small-scale part of the code, so that's really where you should only catch those exceptions you are prepared for. Some people suggest to at least catch exception as it won't include things like system exit and keyboard interrupt, which by design are to terminate your application, but I would argue that this is still far too unspecific. There is only one place where I personally accept catching exception or just any exception, and that is in a single global application level exception handler, which has the single purpose to log any exception we were not prepared for. That way, we can still retain as much information about unexpected exceptions, which we then can use to extend our code to handle those explicitly, if we can recover from them, or, in case of a bug, to create test cases to make sure it won't happen again. But of course, that only works if we only ever caught those exceptions we were already expecting, so the ones we didn't expect will naturally bubble up. Try to avoid passing and except blocks. When explicitly catching a small selection of specific exceptions, there are many situations in which we will be fine by simply doing nothing. In such cases, just having except some specific exception column pass is just fine. Most of the time though, this is not the case, as we likely need some code related to the recovery process, as mentioned above. This can be, for example, something that retries the action again, or to set up a default value instead. If that's not the case though, for example, because our code is already structured to repeat until it succeeds, then just passing is good enough. Taking our example from above, we might want to ask the user to enter a number. Because we know that users like to not do what we ask them for, we might just put it into a loop in the first place, so it could look like this. Because we keep trying until no exception is thrown, we don't need to do anything special in the except block, so this is fine. But of course, one might argue that we at least want to show the user some error message to tell him why he has to repeat the input. In many other cases though, just passing in an except is a sign that we weren't really prepared for the exception we are catching. Unless those exceptions are simple, like value error or type error, and the reason why we can pass is obvious, try to avoid just passing. If there's really nothing to do, and you are absolutely sure about it, then consider adding a comment why that's the case. Otherwise, expand the except block to actually include some recovery code. Except column pass. The worst offender though is the combination of both. This means that we are willingly catching any error although we are absolutely not prepared for it, and we also don't do anything about it. You at least want to log the error and also likely re-raise it to still terminate the application. It's unlikely you can continue like normal after a memory error. Just passing though will not only keep the application somewhat alive, depending on where you catch of course, but also throw away all the information, making it impossible to discover the error, which is especially true if you are not the one discovering it. So the bottom line is, catch only exceptions you really expect and are prepared to recover from. All others are likely either mistakes you should fix or something you are not prepared for anyway. Passing specific exceptions are fine if you really don't need to do something about them. In all other cases, it's just a sign of presumption and being lazy. And you definitely want to fix that.
The main problem here is that it ignores all and any error. Out of memory, CPU is burning, user wants to stop, program wants to exit, Jabberwocky is killing users. This is way too much. In your head, you're thinking I want to ignore this network error. If something unexpected goes wrong, then your code silently continues and breaks in completely unpredictable ways that no one can debug. That's why you should limit yourself to ignoring specifically only some errors and let the rest pass.
Executing your pseudocode literally does not even give any error. As if it is a perfectly valid piece of code, instead of throwing a name error. I hope this is not what you want.
Why is except pass a bad programming practice? Why is this bad? This catches every possible exception, including generator exit, keyboard interrupt, and system exit, which are exceptions you probably don't intend to catch. It's the same as catching base exception. Older versions of the documentation say, since every error in Python raises an exception, using except can make many programming errors look like runtime problems, which hinders the debugging process. Python exception hierarchy. If you catch a parent exception class, you also catch all of their child classes. It is much more elegant to only catch the exceptions you are prepared to handle. Here's the Python 3 exception hierarchy. Do you really want to catch them all? Don't do this. If you're using this form of exception handling, then you won't be able to interrupt your something block with Ctrl+C. Your program will overlook every possible exception inside the try code block. Here's another example that will have the same undesirable behavior. Instead, try to only catch the specific exception you know you're looking for. For example, if you know you might get a value error on a conversion. Further explanation with another example. You might be doing it because you've been web scraping and been getting, say, automatic error, but because you've used the broadest exception catching, your code, which may have other fundamental flaws, will attempt to run to completion, wasting bandwidth, processing time, wear and tear on your equipment, running out of memory, collecting garbage data, etc. If other people are asking you to complete so that they can rely on your code, I understand feeling compelled to just handle everything. But if you're willing to fail noisily as you develop, you will have the opportunity to correct problems that might only pop up intermittently, but that would be long-term costly bugs. With more precise error handling, your code can be more robust.
If you want to see more, please consider subscribing.